Good morning, guys. I just wanted to make this video on domain and range just for some people who have not been in class in person at all this week.
To the main office,
Excuse
Ms.
me.
Calbeck, Mr. Streeter, and Mr. Pendola.
Sorry, guys. So if you haven't been in school at all this week, I just want to make this video because this was the in-person notes that we did. There were no online notes of this. So finding domain and range of continuous graphs, a little different than the discrete graphs. For continuous graphs, you're going to scan your pencil left to right to identify the x values in which are touching the graph. For range, we scan our pencil top or up and bottom or down and identify the y values in which you are touching the graph. So up and down would, or top and bottom would be this, left and right would be this. A few things you should know is you can find domain and range using intervals or inequalities. We're going to stick to interval notation for now. Some things you should know about that: a closed circle. If we have a closed circle, we use a bracket. If we are doing inequalities, it would be when they're or equal to, so when they have a line under them. If you have an open circle, we use a parenthesis. That would be similar to when inequalities don't have an underline under them. Some other things we need to know is if our graph has an arrow going left or an arrow going down, that means it's going towards negative infinity, in which we always are going to use a parenthesis. Whenever we have an infinity symbol, we use a parenthesis. Also, if it's going right and up for any arrows, that's to positive infinity. In that case, we still use a parenthesis. Okay. You also need to know this fancy R. It's 2 lines, and then you just make an R out of those lines. This is called, or means, all real numbers. What it means essentially is that you're going infinitely in both directions. So any number works. The other thing we might need to know is that a U means included. And I think that's it. If I miss anything, I'll go back to it. Okay. So if I look at this picture, I want to see where's it going from left to right. Has an arrow going this way left and an arrow going this way right, which means it's infinitely going left and right. So that means my domain would be all real numbers. My range is top to bottom. So you'll see that graph never goes below my pencil right there. So this is the lowest the range is going to get. But then these are facing up, which means it's infinitely going up, but it's never going lower than this point. That is a closed circle. It's a continuous part of the graph. So I'm going to use a bracket for my lowest point. The lowest point for range, we're looking at y values, is -2. And then it goes up infinitely. So if it's going up, that would be positive infinity. And I need a parenthesis anytime I use an infinity symbol. I just want to also point out, going back to notes from yesterday, this is definitely a function, because if I scan my pencil left to right, I don't have any repeating x values. It's not touching my pencil twice in the one place at all. This one, however, would not be a function because it touches my pencil at the top and the bottom. My domain here, from left to right, it stops at both these edges. So this is -3. That's a continuous part of my function. So I would put a bracket. And this over here is +3, and I would also need a bracket there. Range is up and down, so it never goes above this or below this point, and that's actually -3 and 3 again. And they would still be brackets because this is a continuous part of your function. This one here has an arrow going left, so it keeps going on forever left, and an arrow going right, keeps going on forever right. So my domain is all real numbers. This is an easy one because my range is also all real numbers, because this is going up and this part's going down. So that graph is continuing infinitely, up, down, left, and right. So I could possibly have any number for my domain and range. This one, my domain, I keep going left and I keep going right with these arrows. So my domain is all real numbers, but my range never goes past this top of this mountain here. It keeps going downwards, so it keeps going to negative infinity, but my maximum, the highest it's going to get, is 2, 4, 5. And that is a continuous part of the graph, so I'm going to use a bracket. Remember, facing down is negative infinity. I'll do this and then one more. This one's going infinitely left, infinitely right. I won't do that one because we can do a better one. Let's do this one instead. That one's kind of like one we just did. This one, it goes from here to here for left to right. These are both continuous parts of the graph on all of them because there are no open circles, there are no arrows. This goes from -1 to 1, 2, 3, 4, 5. And then up and down from here to here. I'm at -3, and I go up to +3. I'm going to flip it over, and I just want to do one or two problems with open circles. So I'm going to do 11 and 13. So 11, we have an open circle right here. Might be hard to see from where you are. I'll zoom in. And then we have a closed circle here. So my domain from left to right goes from here to here. This one is a closed circle, so I have a bracket on -2 as my x value. And then this open circle is going to warrant me to do a parenthesis. I got 2, 4, 5 for that one. Then my range goes from this open circle to the top of this. So that's the open circle is at -2, and it should be a parenthesis. -2 on the y values. And then it goes up to +1, and that should be a bracket because that's a continuous part of my graph. Okay, last one here. Domain is going from here, and then it goes infinitely left. So left would be negative infinity. I always have a parenthesis with my infinity symbols, and then it stops over here at x equals 2, and that should also be a parenthesis because it's an open circle. My range does something very similar. This is the highest it goes up here at this open circle, and that's at y equals 0. And then it goes infinitely down, so my lowest would be negative infinity. Hope this helps for anyone who hasn't been able to come into school this week, and hope you have a great day.